Okay, in this lesson, we are going to learn how to represent forces on objects. In other words, how to draw free body diagrams. So these are the learning outcomes: to identify forces acting on an object and draw free body diagrams representing the forces on the object. So before we draw, in order to draw the free body diagram, we have to identify what are the forces first. Okay, some are common forces that we encountered. But in order to identify forces, we must first know which or what objects that we are drawing for the free body diagram. So we have to identify the object that we are interested in or we are drawing for. Then we identify the forces that is acting on the object. So, but take note that it's not drawing of the forces that is exerted by the object. So knowing the forces, okay, we only focus on the forces that's acting on the object that we're interested in. So just imagine that if you are the object and how you are being pushed or pulled around. And remember, it's not about you pulling or pushing, but rather the forces that you are being pulled or being pushed. Take this for example. There are two forces that's acting on A, FA, and there's another force that's acting on B, FB, and in between they are connected by a string tension. So what is the direction of tension force in the rope? And because it really depends on which object we are drawing for the free body diagram for. If you are drawing for A, you'll find that the tension of the rope is in this direction. Okay, so the tension is in this direction for A. But if you are drawing for B, the tension for the rope is in the other direction. This is the tension for B. So you find that the direction of for A and direction of B is actually different. So we have to be clear which object we are drawing for. So similarly, the tension force on the objects will be different for the direction, of the tension force on the wall. Okay, so on the box and on the wall is different. So if it's a box, the tension force is actually lifting up the box. But if you are talking about wall, imagine that you're a wall and then you have two strings that's hanging down. The rope is actually, the string is actually pulling you down, trying to pull you down, okay, if you are the wall. So again, the direction of the force is different for different objects. Okay. So you have these two persons pushing each other. So to this person A's perspective, the push is towards the left. But to the person's B's perspective, the push is towards the right. Okay, so we have to be clear about which object that we are drawing for. So these are some general drawing guidelines. First, identify the object to be drawn for the free body diagram. Then you can simplify the object and just represent the object by a single point or maybe a box or circle. Identify the forces that's on the object. So but take note of that only the forces that is acting directly on the objects included in the free body diagram. Okay, we will talk about this later. Then draw the force vectors to represent all the forces acting on the object. Take note, length of the arrow of course represents the magnitude of the force. Longer means stronger. And the direction of force will always point away from the object regardless of push, or whether is it a push or a pull. Then label the forces with the help of a legend. Okay, so we'll use one example. An apple that's on top of a book that's placed on the table. Okay, so let's just draw an apple and a book first. Then there's a finger that's pushing the apple towards the right, but the apple remains stationary. Okay, so let's draw a free body diagram for the apple. Okay, since free body diagram of the apple is for the apple, you only focus on the apple, which means that the finger and the book actually doesn't take into consideration. Okay, you're not drawing for the finger, you're not drawing for the book. So identify the forces that is only on the apple. So what are the forces that include? Okay, first thing first, if it's on earth, definitely that's the weight of the apple. Okay, So the gravitational force apple by the earth, and generally it's towards the center of the earth, but we just draw it pointing vertically down. Okay, so this will be the weight. And of course there's a push by the finger, so it is in this direction. Okay, notice that the apple is stationary, so which means that there must be some forces that's actually balancing or countering the weight and the push. So countering the weight is actually a normal force by the book, and in this case must be upwards. So the book is supporting the apple. And since there's a finger push towards the right, but yet the apple doesn't move, which means that there must be some forces that's countering towards the left, and in this case is the friction provided by the book. Okay, so after identifying all the forces, you can represent the apple by just a single point. Okay, so a single point will represent the apple. You don't have to draw the entire apple with its leaf and stalk. Just represent the apple by a single point or a single dot. Then you move the forces to the point so that the forces arrow will face outwards. Okay, so all this would be the forces. Okay, you find there is a clearer representation, and the forces that's always facing outwards. And label the forces with the help of a legend. So A for apple, B for book, E for earth, and F for finger. These are the forces. So these are forces: weight, friction, push, and the normal force. Okay, we'll talk about the representation of this subscript in the next slides. Okay, it is a good practice to label the forces so that we can be more clear about the which is the object that's exerting the force and which object that is exerted on. Okay, so take weight EA as example. What does this EA means? It means that the force is weight that's exerted by the earth, represented by E, and on the apple. So normal BA, you can infer that it is the force that's a normal force that's exerted by the book and on the apple. Okay, it is actually alright that you label as W and N. Okay, as long as people understand that W means weight and N means normal. Okay, why is this important, or why is this good practice? Is because if you have multiple objects, so you find that you have two forces, this person is pushing, this person is pushing towards the right, this person A is pushing towards the right, B is pushing towards the left. So how do we represent the forces? Okay, you find that actually you should shift this in this manner. It is because the blue force, the force by B on A is pushing towards the right, and this is the force represented to push by A on B. Okay, you find that this will be useful when you encounter Newton's third law. Some other points to take note: the apple is actually on the book that is on the table. Okay, notice that our previous case we didn't include a table. Why is that so? Okay, shouldn't we also include the normal force that's supported by a table, because the book is actually not floating in air, it is actually supported by a table? Okay, but we do not do that is because we only include the force that's directly on the apple, since the free body diagram is for the apple only. If we have to include the table, it is very difficult to draw the line. Okay, where to so-called draw the line? It's because if we include the support from the table, then shouldn't we also include the support by the floor? Okay, because the table is not floating in air. Okay, and if the floor is actually, what about if the floor is actually not on the ground but in a tall building? So do we need to include the office building? So the point is that if you just only for the apple, it's just only on the apple. We don't think about whether is it the apple is on the book, that's on the table, that's on the floor, that's on the tall building, and so on. So we simplify it. So if it's on the apple, we only focus at the normal force by the book. So we only identify or draw forces that's immediately acting on the object, in this case the apple, which is in contact with the book. So we need not draw the forces that's not affecting the apple directly. Similarly, Okay, you have this box and this person that's pulling very hard. Despite the obvious effort put in by this person, if we to draw the free body diagram for the box, okay, we should only label the force by as a force that is pulling towards the right, okay, and in this case is by the rope, okay, and not the person that's on the box. Okay, so because if we were to include the person's force, we should also include the frictional force that's actually supporting this person in terms of pulling. Okay, so again we do not do that, so we only focus on the forces that's directly on the object, which is case is the box. So you don't care about whether is it a person that's pulling or is it a cow that's pulling or car that's pulling. You just only know that there's this rope that has this provide this tension force that's pulling. Okay, that's it. Okay, so I hope that you learn how to draw a free body diagram. That's all.